Right, this video is going to give a quick explanation of why the marginal revenue of a monopoly is decreasing and why it decreases faster than the demand curve. And this is going to be a calculus-based explanation. Feel free, if you don't have a calculus background, to skip this video. It's not in the AP curriculum, but I think it actually makes a lot more sense in terms of how to think of the revenue function for a monopoly. So in the previous video, I had a table right here that worked off of this demand curve. It's a very simple demand curve. When the price is 20, the quantity is going to be 0. That's like the intercept. And the slope is -1, so when the quantity goes over 1, the price has to go down. So to sell 1 more, you got to bring the price down by 1. It's a very simple revenue curve, and I'm going to draw it. Or sorry, it's a very simple demand curve, and I'm going to draw it here. Here's the intercept, 20, and it's linear and it goes down. And here's the quantity intercept. So if the price was free, if that was 0, we can solve for that. Okay, that's 20. And there's the demand curve. What we care about with monopolies, because monopolies can choose their price. Monopoly can say, all right, I'll produce right here. I'll charge $19 and produce 1. Or I'll charge $1 and actually sell 19 of them, right? That's different. And somewhere along this line is actually the optimum, the maximizing revenue for monopoly. We'll look at how we figure that out. Remember that revenue is the price you sell something for times the quantity. So if I charge $19 and sell one thing, my revenue would be $19. If I sell 2 things, and if I look up here, I would have to charge $18 to sell 2 things, I would have $36 of revenue. If you look at the last video, we can measure each of those changes in revenue by looking at the marginal revenue. But where does that come from? I'm going to substitute this equation in for P. I just substituted, this is just price times quantity. And the price from up here is -Q plus 20. Now in calculus, let me simplify this quickly, just distribute that in. This means that the revenue is, what's this, -Q squared plus 20, is actually an upside down parabola. I'm going to draw it right here. Distribute that there. Try to get these to align here. Well, if you charge $0, you can sell 20 of them. That's great, but you're bringing in 0 revenue. So somewhere there's a maximum of this revenue. So this is revenue that a firm has for selling a certain quantity. Well, the marginal revenue, this is a calculus-based video, the marginal revenue is just the slope. And what's the slope? It's just the derivative. This is, you don't need to be in any advanced calculus. I'm sure that if you're in any calculus class, you've taken a derivative. And a derivative of the revenue is the change in revenue for change in Q. And that's just the marginal revenue. Well, take the derivative of this. This is just a simple quadratic. -2Q plus 20. And this is the marginal revenue curve. All you've been doing is taking a derivative. The slope of the marginal revenue curve is twice as much as the slope, looking all the way back up here, of the demand curve. Remember, this is the demand curve that a firm faces, a monopoly firm. They can choose where they want to be on there. Well, the marginal revenue has the same y-intercept. This is the $ symbol. But the slope is twice as much, so the x-intercept is going to be halfway, 10. If you look at some AP Micro intro books, they might just say that this is twice as steep. Well, that's based on an assumption that the demand curve is linear. So the revenue curve is a parabola. So yes, the slope is twice as much, going down negative. This is called the marginal revenue curve. And it's okay to have some of this in the negative in what is it, the 4th quadrant there, because what happens here? The derivative, the little slope here, is positive. You sell 1 more, you're making more revenue. But remember that when you sell 1 more, In order to sell one more, you have to lower the price. And when you lower the price for everybody. So at some